Good day, students. Welcome again. Once again, I hope you are enjoying the videos that I'm uploading on my channel, Chemistry World. Today, I'm going to talk about solutions. What comes to your mind when you hear the word solution? I'm not talking of a mathematical solution here. I'm talking of solutions that we have in chemistry. Basically, for us to form a solution in chemistry, we need two things, all right? For us to form a solution, we need the solid, okay? And we are going to add our solid to a solvent. And we can put an arrow here that in most cases, for us to form a solution, we are going to have a solution as a product of the solid and the solvent mixed together. This would be a physical change because we can reverse it. It's not going to be a chemical change. So in most cases, for us to form a solution, we need a solvent and a solid. What is a solvent? A solvent is any substance that allows other substances to be dissolved in it. A solid is the substance that I am going to dissolve. Okay? So we can give an example that we have at home, and I'm just going to demonstrate that in a few moments. So the solid, which we can think about at home, we can have salt, and then we have water as our solvent, okay? And the result is we are going to produce what we call a salt solution, okay? Water is a universal solvent. It dissolves a number of substances. That's why we find it in plentiful supplies in nature, because it's a very useful solvent. So if you are going to demonstrate the formation of a solution, I could have water in this glass. Water is a solvent. So if I take just a few grams, of salt, and then I put them into this water, okay, and then I agitate. And by the way, agitation like this, you are causing the solvation process to occur faster. Okay? Now, if you look at the solution that I've produced, the salt has dissolved. Okay? I can, just to be sure, I can stir again, and I have formed a salt solution. If I look closely in the solution, I don't see any differences here. So we say we have actually formed what we call a homogeneous solution. Okay? This means the same. It's uniform. I'm not seeing any substances hanging in solution. In other words, a salt solution is a homogeneous solution. Obviously, what we are also saying here is that if there is a homogeneous solution, it means there should be a heterogeneous solution. Heterogeneous solutions are easy to demonstrate when we are talking of two solids or two liquids that have been put in the same container. Let's see whether we can demonstrate that for us to learn more about heterogeneous solutions. Okay? I have two solutions here. Okay? I have oil and I have water. These are two solutions. But let's mix them and let's find out whether we'll be in a position to form a homogeneous solution. All right? So I'm putting oil in water. You see, as the oil enters the water, you might think they two are going to mix. Okay? But if you let them to settle, you're going to find out that you are going to have two distinct layers, which means oil and water, even if you agitate, they are not going to mix. Okay? Even if I stir them like this, during the agitation process, it appears they are going to mix, but on settling, still we are going to have two distinct layers. What does this mean? This means these two solutions will never mix. Okay? There's a term that we use to describe two solutions that will never mix. Okay? First of all, we should say that we have formed a heterogeneous solution. All right? There is no uniform mixture. The two solutions are described as immiscible. Okay? That's the term that we use in chemistry. Immiscible. Okay? Immiscible means not mixing. Okay? They don't mix. So we use the term immiscible. They are immiscible because we have a rule in chemistry which says like dissolves like. Okay? Water and oil are different. Okay? The nature of these two substances are different. That's why we are seeing two layers. Oil is non-polar, but water is polar. So a polar solvent will also dissolve a polar solid. Okay? Polar will dissolve polar. Non-polar will dissolve non-polar. So if we put a polar substance and a non-polar substance in the same container, they'll never mix. Okay? The rule is like dissolves like. Okay? I could just give a very simple example in ordinary life. Sometimes you can hear some people saying, yourself and myself, we're like oil and water. What are they saying? They're simply telling you that you will never mix. Maybe they are polar and you're non-polar. Or you are non-polar and they are polar. And because that basic characteristic is important in as far as mixing is concerned, the two will never be compatible. So immiscible means not mixing. Okay? If I had a another polar substance like ethanol, for instance, if I put ethanol and water in the same container, if you stare, you will not see two distinct layers like this. Why? Because ethanol is polar. Water is polar. So if you put them in the same container, they will mix very well. Okay? But remember this rule. Okay? Like dissolves like. That's the rule that we have. Okay? And immiscible, the opposite is miscible. Okay? Miscible. The miscible, they mix as well. They mix well. Okay? And what we are simply saying here is the fact that in as far as solution formation is, we can have miscible and immiscible solutions being put in the same container. And what you should take home here, students, is like, okay, dissolves like. Okay? This rule is very, very important. Okay? For compatibility purposes, like will dissolve like. Okay? But there are some substances that we can have in the home which will not form solutions. If we don't form solutions, what then do we have? Okay? Sometimes we put a substance in water and we don't form a clear solution like what we saw when I put salt in water. What is that called? Let me just show you that. Okay? Just have water here. All right? And what I'm going to do is I'm going to put flour, not salt. Okay? This is flour. I'm putting flour in water. Okay? I've dissolved just about a half teaspoonful of flour. Okay? Right. We don't have a solution here. Okay? What term do you think we use to describe this? This is not a solution, but it is called a suspension. Okay? If you look at a suspension, you are going to find out that the particles in a suspension, the particles will be hanging in the liquid. So suspension, okay, is different from a solution. Okay? If I put salt in water, I would form a solution. But if you put things like flour, like what I've just done, sand, okay, soil, or even chalk, okay, you form a suspension. Okay? Let me just check whether you still remember this. For salt to be separated from water, the method of separation would be evaporation. Okay? You can evaporate the water and this the mixture will be separated. But I cannot use evaporation here. Why? Because these substances are not completely soluble in water. We can simply use filtration to separate them, okay? I'm just trying to link method of separation to this topic so that you'll be in a position to remember that we are forming physical change here, and these are not chemical changes. We can simply reverse. I can stir and then I filter. If I filter, I'll get my water back and the flour also being trapped by the filter paper. So I would use filtration for separating my flour from water. It is a suspension, okay? As you can see, when I look through a suspension, it's not transparent, okay? I can't see through it, but if I dissolve salt, it's a transparent solution, okay? This one is opaque. In some cases, some solutions will give you maybe a translucent, okay, where it's partly clear, it's sort of hazy. You cannot actually look through and you see what is on the other side of the suspension. So you need to know these terms that I've covered so far, okay? Homogeneous, heterogeneous, miscible, immiscible, suspension, and solution. These two are different, okay? Just to end off today, I'm just going to talk about the differences between a saturated solution, unsaturated solution, and supersaturated solution. Okay, but before I leave suspension and solution, just be aware of the fact that, okay, if you look at your suspension and your solution, okay, right, that is a solution. Okay, I hope you can see that. And this one is a suspension. Check the difference. So whenever a person tells you that, okay, I have two mixtures here, which one is suspension, which one is solution, you should be in a position to tell. Okay, I look through my solution, I can see what is on the other side. I look through my suspension, I can't see what is on the other side because the suspension is translucent, okay, but my solution is clear. Okay, now let's just summarize what we mean by saturation and unsaturated. Okay, when we say saturation, okay, if I dissolve a solute in a solvent, okay, I put salt in water, okay, if I say salt plus water, I'm going to form a salt solution, okay. But if I take the solution which I formed here, I'll show you the solution again. If I take the solution which I formed here and I continuously put salt into this solution, what do you think will happen at the end? Yes, you're correct. At the end, no more salt will dissolve because salt has a certain solubility at a given temperature. Okay? So for us to, when salt dissolves, okay, when dissolving occurs, okay, for us to have dissolving occurring, all right, when dissolving occurs, it means we still have unsaturated solution. As long as we have not reached the saturation point, we put salt, it will dissolve, okay? But when dissolving stops, okay, dissolving no more occurs. What is that referring to now? We have reached saturation, okay? Just a bit of chemistry. When I dissolve something, you know water has spaces between it. So the solvent, when you dissolve salt into water, the solute particles will be fitting in the spaces between the solvent particles. So putting more and more of the solute, the spaces between water particles will be fully occupied. And as a result, if you put more salt, there is no more room to dissolve. The only possibility for you to dissolve is either to increase the volume of the solvent. If you increase the volume of the solvent, you are introducing more room. So more solute particles can be accommodated. But besides that, I can still keep the same volume of the solvent. I don't change the volume of the solvent. What I'll simply do is to introduce heat. If I introduce heat, the kinetic energy of the solvent particles will increase. And because the kinetic energy of the solvent particles has increased, I will be in a position to dissolve more. Okay? Remember, I've reached saturation, but what I'm simply doing now is to heat. By heating, I'm promoting collisions between the particles of the solvent and the solute, and I can allow more solid to be dissolved. And as a result, you're going to find out that you can actually have what we call a super saturated solution. You have exceeded saturation, but by heating, okay, after heating, more dissolving, okay, occurs, and as a result, you reach what we call super saturation point. So, solubility is usually coated at certain temperatures, and once we exceed or once we heat, we are in a position to actually increase the solubility of a substance, and that will allow us to reach a point which we call super saturation. So, three terms: unsaturation, saturation, and supersaturation. These 3 points must be so clear in you so that you are in a position to form, to understand how solvation occurs. This was the lesson today. We're talking about solutions, okay, how we form solutions, and important terms that are associated with it. In my next lesson, I'm going to look at concentration. How do we describe the concentration of solution? We'll be focusing on terms like molarity, molality, and also look at how can we look at the percentage, okay, of the solute, and we compare it to the whole solution, and what is that called? A bit of calculations there, and then we'll be in a position to understand solutions more. If you have enjoyed this video, please remember to subscribe to my channel, like it, share it with your friends, so that at the end of the day, your friends will also benefit. Thank you, students, for listening to this session. Bye for now.